Algebra I 11.4c, rational exponents. Those are exponents that are fractions. We can simplify expressions that have rational exponents. Yes, exponents can be fractions, rational numbers. So here's the definition of a rational exponent. If we've got a and the exponent is 1 over k, it's the same thing as saying the square root of a with the k there. See there? As the index. The k is the denominator of this rational exponent. See? For any natural number k and any a, as long as a is greater than 0. Remember, the product rule for exponents tells us to add exponents when multiplying. So if we have a to the half times a to the half, it's going to equal a to the half plus half. That's going to give us a to the first, isn't it? Which is just an a. We can plug numbers into this and it'll be the same thing. If we have 3 to a half times 3 to a half, just like these, it's going to be 3 to the half plus half. That'll give us 3 to the first power, which is a 3. We can define 3 to the half power as the square root of 3. And the same rules we use for integer exponents will work because the square root of 3 times the square root of 3 is the same thing. It's equal to the square root of 3 squared. That's 3. See? I know this sounds confusing, but just keep watching and this will all make sense, okay? So, if we need to simplify this 25 to the half power, remember from before, a couple videos ago, we talked about cube roots and we put a little 3 there. Well, actually, the square root is really the same thing as having a little 2 here as an index. We just don't usually put that little 2 there. We put it there when we have a cube root, don't we? But when we have a square root, there's actually a little 2 that we could put there. It's just nobody does it. So, because we're going to put that denominator there as the index, that means we really just have a square root, don't we? So 25 to the half power is the same thing as just 25 squared. And the square root of 25 is 5. See? We got a little 3 for a denominator, so that's going to go there. So now we need a cube root for 8. 2 times 2 is 4 times 2 is 8, so that equals 2. See? When we see it in parentheses, that means we have to multiply 9 to the half power 3 times, don't we? And because 9 to the half power is the same thing as the square root of 9, right? That little 2 would go there for the denominator. So it really just means the square root of 9 times the square root of 9 times the square root of 9. Well, the square root of 9 is 3. So it means we have 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So this equals 27. Let's try another one with parentheses. This means the cube root of 64 times the cube root of 64. See? The little 3 denominator goes there as the index. And you need to find out what times what times what. What 3 digits multiplied together would make a 64? It would be a 4. 4 times 4 is 16. Times 4 is 64. And this equals 4 and this equals 4. So because they're multiplying together, that means we have 4 times 4. 4 times 4 is 16. See? Check this one out. Now we've got 125 to a third power, and it's got a 3 exponent on the outside of the parentheses. Well, this means we have the cube root of 125, because the little 3 denominator is going to go there, right? So we have the cube root of 125 multiplied by the cube root of 125 by the cube root of 125. Well, the cube root of 125 is 5 times 5 times 5. That equals 125. The cube root then is 5. See? That's the number that multiplied to itself 3 times makes a 125. So that means we have 5 times 5 times 5. And it goes back to equaling 125. See? It's kind of like you're saying 3 over 3, which makes it 125 to the first power, which makes it 125, right? So check it out now. When we have 25 to the half power, that's the same thing as saying the square root of 25, right? We need to multiply the square root of 25 by the square root of 25. Square root of 25 is 5, so that means we have 5 times 5. That's 25. And look, this 2 times the 2 here would be 2 over 2, wouldn't it? So it'd be 25 to the first power. So it is 25. See how that worked out? Yeah, we can do this, right? Even little 0 says we can do this. It's not that hard, all right? So our next video, 11.5a, we're going to discuss dividing with radicals. And of course, any of the previous videos, we just did multiplying radicals and cube roots. Any of those previous videos for chapter 11 are going to be in the description of this video, so you can just click on it and go back and review, all right? All right, I hope you're okay. If this was confusing, try watching it again. And I tried to explain it as best I could. Let's talk about dividing radicals, all right? I'll see you next video. Bye.